Good morning and welcome to IMW's webinar, Renewable Natural Gas from Production to Pumps, an important biogas primer. Our speaker today is Nicholas Lumpkin, Director Business Development at Clean Energy Renewable Fuels. And with him is a technical team supporting this session. Steve Smith, professional engineer, John Cowie, engineer, Clean Energy Fuels, and I'm Dave Orton. I'm the Senior Vice President, Global Business Development and Marketing, IMW Industries. IMW has been manufacturing since 1912, and we are exclusive manufacturers of non-lubricated CNG compression technology. We are a wholly owned subsidiary of Clean Energy Fuels out of Los Angeles, California. And Clean Energy Fuels runs a network of over 450 CNG stations and 120 LNG fueling stations across the United States. Just a reminder, we do have professional engineers in attendance and supporting this webinar, and as such, it does qualify for a 1-hour technical informal credit, and if you signed up under your own email, that will automatically be released to you. If you are gathered around a boardroom table, please take a roll with the appropriate names and emails, send them in to webinars at imw.ca, and we'll ensure that you receive the appropriate proof of attendance so that this will apply to your technical information credit. Again, our primary speaker here is Nicholas Lumpkin, Director of Business Development for Clean Energy Renewable Fuels. And at this time, I'm going to pass it over to Nick out of our California offices. Over to you, Nick. We're just passing it to you now.
Well, good morning, everyone, and thanks for joining us today. As David mentioned, you have Nick Lumpkin with Steve Smith and John Cowie as well from our operations and engineering team, who I think most effectively we can have a couple Q&A sessions. I'll kind of take a first swing on the top side of supply chain and walk through viable projects and considerations that need to be made, and then we can move into kind of end use and some of the impacts on pricing that the environmental attributes have, and what the benefits for fleet customers could be ultimately as the second half of the discussion. So without further ado, I work again for Clean Energy Renewable Fuels. We're a sister company of IMW, same parent company, Clean Energy. We currently have 700 plus fleet customers, do 9,000 plus transactions per day, 30,000 natural gas vehicles fueled daily, and roughly 500 plus natural gas fueling stations around the country. That's important to us on the production side of renewable natural gas because that represents a home for, the biomethane that we produce at our facilities. Again, Clean Energy, vertically integrated company. Obviously, IMW focuses on compressors and equipment. We're on the renewable fuel side, so I'll be focusing on those two icons to the upper right today. But Clean Energy has a portfolio of solutions and really can address any fueling needs that a fleet customer might have. Into our role, Clean Energy Renewable Fuels, we're a producer, marketer, and distributor of renewable natural gas, also known as biomethane. So we have production assets that we own and operate. We also work with third-party producers to purchase their gas and effectively distribute it through our parent company's fueling stations and sell it as renewable natural gas to fleets who can then recognize the carbon benefits of using a low-carbon fuel. It's pretty seamless. Obviously, renewable natural gas is a drop-in fuel, and I'm going to talk about how seamless it really is. You're going to see this slide a number of times. I think it speaks, obviously, to the whole supply chain, and again, I'm going to focus on kind of the top half. Clean Energy's core competency and really core business to date has been focused on number 4 here, the fueling station piece. So we've been involved upstream of that and I'm going to start by focusing on the capturing and extracting methane from organic waste, and then obviously we have to process and purify that to make it a usable fuel. So moving forward, I guess I'm going to step back there. In terms of feedstocks and viability for projects, before I talk about our projects, wherever there's organic waste, ultimately we can derive methane. Certainly you need to have substantial mass to generate what would be an economic project from that methane, but feasible feedstocks include municipal solid waste, food waste, animal manure. We're seeing more movement in the dairy farm and hog farm businesses. Energy crops are another additional feedstock that can generate methane and enhance your production with a digester. Our group isn't necessarily, we wouldn't claim to be experts in the field of digesters. There are thousands of them in Europe. Our focus has been based really in the landfill side, where you have anaerobic digestion taking place underground effectively, and you get the same results. You get about 55% methane, the balance being CO2, some hydrogen sulfide, and other constituents in the gas. From there, we capture that methane at a landfill. It's through the well field, and we have some say. In fact, we operate the well field at the City of Dallas so that we can manage gas quality and introduce that to the plant so that the plant has better defined parameters for purification. Just another note there on technologies for purification. There are several. There's pressure swing adsorption. You can use water wash, amine wash, membrane technologies. A lot of technologies available, and we apply a couple of them. And as we get into the Q&A, Steve and John can speak very intimately about those processes. So I'll move on to our plants. McComas Bluff, again, City of Dallas owned landfill. We operate that well field. It is, I believe, the largest biomethane facility on the planet, certainly in North America. We're currently doing about 6,000 decatherms a day, and we're ramping up so that we can distribute about 60,000 gasoline gallon equivalents a day, which is sizable when it comes to renewable production facilities, renewable fuel production facilities. There we use a PSA. We've done an expansion, and since we acquired it in 2008, and have ultimately ramped up production by about 5x. So we're excited about that, and it's been really ground zero for our group, and was the first to get registered with the EPA to generate RINs and so on and so forth. But I'll talk about that later on in the presentation, the impact of that. A second project we have is up in Canton, Michigan. It's just outside of Detroit. There we use a water wash system, ramping that up to about 20,000 gasoline gallon equivalents a day. With that project, we've sent some of the gas into the pipeline and dispensed it as LNG. So we sent it through the interstate pipeline network from Canton, Michigan to California, and have sold millions, ultimately, of gallons of renewable natural gas through clean energy fueling stations. Sorry. A third project that we're in the process of commissioning right now, in fact, John's out there as we speak. This is a landfill owned by Republic Services, as was the Canton project. There we're using a PSA system, a little bit smaller, but this landfill has a lot of potential for growth. So we've built it out in a modular fashion so that we can expand it. And initially we'll be doing close to 15,000 gasoline gallon equivalents a day. Considerations that I should mention regarding feasibility of these projects. Key things that we consider going in, and certainly having access to long-term feedstock. So whether it is a landfill or you're looking at a digestion, you're going to want to know you have a feedstock for the long haul. These projects certainly need 10 probably 20 years in a lot of cases to really pencil. So having security around that feedstock is a critical piece. Second is certainly power availability. There's parasitic power that is required for processing gas regardless of the technology you select. So that's a critical piece and can have cost implications. A third one to us, and really most importantly with our business model, is having access to a pipeline. It doesn't necessarily have to be an interstate pipeline. We've gone into local distribution companies as well. But our business model is ultimately to capture sizable volumes of gas, purify them, go to the pipeline, and really utilize the millions of miles of pipeline in this country to move gas from point A to a number of different distribution points. So those are key considerations as it relates to feasibility of these projects, and all of them ultimately are critical. And Steve can certainly, as well as John, speak to some of the challenges there with working with the utilities and making sure that everything's lined up so that a project can be successful. If Dave and James, you think now is a good time to take Q&A, or I can move forward onto the kind of the second half of the supply chain if you see fit.
Yeah, we're just we got a couple of questions coming in here. How much raw biogas do you need to justify pipeline injection?
Again, for pipeline injection, this is Steve Smith. For pipeline injection, generally from an economies of scale standpoint, you want to look at probably around 1,000 SCFM minimum. A lot of that depends on how far away that pipeline is. Obviously, if you get 1,000 SCFM plant and you get a 5-mile pipeline to build to get into an interstate or a local line, the economics are probably not in your favor. But you know, if it's closer, 20 feet really works really well if we can get in that quick. So again, it is dependent on a couple of different factors that Nick has identified already. But that's kind of a general rule of thumb that we use when we're looking at evaluating. There's about 1,000 SCFM at the inlet.
Okay. Another quick question. You talked about having proximity to a pipeline. Do you see justification for you know, accessing a stranded asset using virtual pipeline or rolling pipeline with sort of a mother-daughter station setup?
It can be done. I am aware of 2 projects that are at least conceptually being put together in that manner right now. I don't believe there's anything actually, you know, except in very, very small quantities when you're talking a package. There are some smaller package plants that are out there doing it. There's also some opportunities for, particularly in the smaller package plants, you know, I'm talking 100, 300 SCFM type facilities, to direct fuel, particularly if you have vehicles co-located in, you know, in a similar position with either an anaerobic digester or a landfill. So yeah, there are opportunities. It is an up-and-coming item, and it is certainly conceptual at this point. We are trying on a couple of projects to make it work.
Okay. Just one more here before we let Nick continue. What are the biggest challenges you have as it relates to interconnecting with the gas utility?
Generally speaking, that's the gas utility itself. Each one's a little bit different. If you've ever worked with a utility, they can be a little cantankerous sometimes. But you know, the biggest issue typically is getting your engineering designs approved, whether or not they have to do the engineering design, whether they have to do the construction, or whether they allow you to self-perform and then feed the pipeline back to them. The latter is generally a much quicker process. We've done that in 2 of our projects. In one of our projects, we had to allow the utility to actually build the pipeline, et cetera, and you know, they took 2 years to do all that, whereas you know, typically we're done with our pipelines in somewhere in the 4 to 6 month basis. So you can bring, you know, CapEx, your capital online quicker, obviously producing revenue. So all those things are a factor, if you will, when you look at the utility.
Great, thanks very much. Okay, well that's enough questions for this moment. Nick, back over to you.
Great. So picking up where I left off, and I think Steve's answers were a good segue into really the next step. There's really three things you can do with the biomethane. If you go power on site, you certainly don't need the technologies that we've discussed to put in a genset. And the majority of landfill gas projects to date have actually been raw biogas to power with some conditioning to gas, but you're not getting up to pipeline standards, certainly. So at the back end of the plant, the considerations then are, do you put on-site fueling station in if you're going to go transportation fuel, or do you go to the pipeline? And with the economies of scale on the projects that we're pursuing, typically we're going to the pipeline. You can do both. In fact, both is a fine option if the fleet that's delivering the feedstock or is part of the operations of the facility has an interest in utilizing that fuel. It's a great option. But ultimately, going to the pipeline gives you the ability to produce a lot more gas without having to match your supply with demand. And again, having millions of miles of pipeline around this country, you can ultimately move this gas contractually, if you will, but across the country, and we do that on a daily basis. So once going into the pipeline, we can go to a liquefaction plant, we can go to our existing CNG stations, or you can participate and sell it to a power utility if they have an interest in biomethane and their state has aggressive renewable portfolio standards. California did. They closed the market to out-of-state biomethane basically a couple years back. But that was an option, and there are other states, notably in the Northeast and East Coast, that are still allowing biomethane to come in, and you can generate renewable electricity and RECs from burning that fuel in your plant. And it's similar. I mean, effectively, it's a drop-in fuel that's displacing fossil natural gas and can distance end users from some of the fracking discussion that different people have different stances on. So moving along, again, we're a vehicle fuels company, but we truly believe that the best and highest use for biomethane is in the transportation sector. There's not a whole lot of renewable fuel that can be produced at the volumes we can produce this gas that can displace gasoline and diesel at a discount. You know, our biggest challenge is with very cheap natural gas being cost competitive. You know, last week gas was under $4 a decatherm. Our production costs are a little greater than that, but ultimately we can compete with gasoline and diesel all day long, and that's an exciting proposition when you consider the carbon reductions that using our fuel can provide.
Nick, we've got quite a number of really good questions coming in here, so maybe we can just pause and grab a few of these.
Sure.
Frank is asking, how does biomethane compare to compressed liquid natural gas in terms of energy content? Sorry, compressed or liquid natural gas in terms of energy content.
Once we go to the pipeline, in order for us to inject gas into the pipeline, we have to meet the gas specification of the utility. So we're producing gas that's really on par with what's already in the pipeline. There's some high gas in some of the shale plays around the country, but we're looking at anywhere from 950 BTU gas up to 980. Steve and John, if you guys want to interject, please do. But at the end of the day, once we're in the pipeline, we have a fungible asset, and when we liquefy it, you know, 1,000 miles across the country or compress it at a station a couple hundred miles down the road, we're tapping into a fungible marketplace, and you're getting natural gas. Really, the offset happens at the production facility.
Interesting. Okay, now this one's a good one from Rob. Which biogas purification technology is the cheapest in the small-scale investment, and which one is the optimal from cost and efficiency point of view?
A lot of that depends upon the source of the biomethane. For instance, if you've got an anaerobic digester that's being fed very clean materials such as, grass clips, trees, manures, etc. Very minimal chance of VOCs, minimal siloxane, some of those types of things. Better, you're probably looking more at a water wash type of process from an economies plus power use. Gives you drop the cost per MMBTU probably lower. However, if you're looking at landfill, or you're looking at some other more heterogeneous type of waste material with some of those factors factored in, a membrane or the PSA, TSAs, again, the biggest factor between those two is going to be power use. So, if you're in a location, maybe in the Northeast, and, power's 16 cents a kilowatt hour, you're probably going to be better off with a PSA because the membranes use a little bit more power. If you're in, a location where you're deregulated states such as Texas, for instance, you can get, 10-year, 8-year power contracts for 8 cents a kilowatt hour or 6 cents a kilowatt hour. Then you might look at, either one, but the membranes may be more costly.
Actually, that rolls right into Terry's question here. What is a typical parasitic load % biogas consumed?
It typically is about somewhere near, well, it depends again on the process, it depends on the size, the economies of scale, but it's somewhere between 17 and 28 kilowatts per MMBTU produced. For instance, our Dallas plant is much closer, obviously, to the 17 because of the economies of scale. You're producing 6,000, 6,500 MMBTUs a day versus a smaller plant, maybe in the 26, 27 kilowatts per MMBTU.
Okay. The questions keep coming in. They're really good, but I want to let Nick finish the presentation. So, folks, keep on sending your questions in, and obviously we'll have a fairly lively after-presentation Q&A here, but I'll let you continue, Nick.
Okay, great. Thanks, Dave. So moving on, going into the pipeline, moving to the economics of that scenario, and specifically going to transportation fuel. What you see here is natural gas commodity, really Henry Hub tracking across the page over time. It doesn't have the last couple months. If it did, you'd see a little dip there towards $4 is that blue line trailing across the page. The bandwidth you see between the red line and the black line, labeled RNG high production cost estimate and RNG low cost production estimate, that's really what it costs us to produce gas. And there's a wide range, again, because it relates to economies of scale. If you have a digester, you're going to be closer to that top end because you have an added capital investment. But at the end of the day, we're comfortable in the I'd say 5 to 8 range as it relates to landfills. But in a $5 gas market or a $4 gas market or sub $4, we have some work to make up. And the way to do that really is to monetize the renewable and carbon reduction aspects of the fuel. In doing that, there's a couple programs we participate pretty heavily in. There's a lot of movement in the renewable fuel standard. This is something that the EPA set out under, actually under Bush and Congress. But the renewable fuel standard basically stated that by 2022 there'd be 36 billion gallons of renewable fuel in the overall fuel mix in this country. So this is what they set out as a target. You can see the ramp up there, giving producers time to ultimately step up and contribute to meeting these goals. The bottom category is really corn-based ethanol, biogas or biomethane from landfills, from digesters, wastewater treatment plants. To date, we've been classified as an advanced biofuel, which is that top category. About a month ago, the EPA came out, and due to the makeup of the waste in landfills and the process and production of manure and some of these other feedstocks, it's actually been reclassified to meet the cellulosic biofuel category, which has positive economic implications, or at least should, and you can see that's where most of the ramp-up comes in that brighter green color kind of through the middle of this chart. So that should be a very positive, have a positive impact for renewable natural gas in the long haul. We're waiting for the EPA to come out with their required volume obligation as it relates to these fuels, and as they do, it'll set the demand for the obligated parties, who are the big oil producers and refiners in this country, who have ultimately been tasked with bringing 36 billion gallons into the fuel mix of renewable fuel. So with that, ultimately we generate what's called a RIN when we dispense biomethane as a transportation fuel, and that can add anywhere from $3 to $12 a decatherm of value if you look at it over the last, say, 2 to 3 years. And as a result of that, we've had pretty good revenue income from selling RINs on top of the gas value, which really trades based on its local indices. In California, we have the low carbon fuel standard, and this speaks to specifically to the carbon reduction provided by each and every fuel. So biogas is a participating fuel. Conventional natural gas is also a participating fuel. The goal here set by California was to reduce the carbon intensity of transportation fuels by 10% through 2020. Right now, the California Air Resources Board is readopting the low carbon fuel standard, but we've generated and sold $10 million worth of LCFS credits related to both conventional fossil natural gas as well as renewable natural gas. And we see 4 to 5 times the carbon reductions when you move from conventional off the baseline diesel down to landfill gas, and in some cases these digester projects have a negative carbon intensity, so effectively a carbon sink. What does that mean economically? I'll show that, but where it can have big impacts is really when fleets show up and are burning a carbon negative fuel. It goes a long way to meet their corporate sustainability goals. And really, this fuel should really get a lot of attention in that space. If we look at the low carbon fuel standard credit market, this is what it had looked like over the last, say, 18 months. You can see a big run up at the end of last year. Then CARB is effectively readopting. There have been some lawsuits, and the prices have come off, but this thing should move forward. And right now, we're seeing a roughly $30 price. That equates to about 5 cents a gas, maybe 4 cents a gasoline gallon equivalent of value. Again, it's going to depend on the carbon intensity of your biomethane, but it's real value. So availability. Right now, there's a growing demand for biomethane for CNG, LNG, as well as electricity, and it really all speaks to that major discount in carbon emitted. It's actually carbon equivalent, so it factors in your NOx and methane that may not be combusted in the process. But as we move forward, I think demand will continue to grow as awareness about the product increases. And with that, we assume, or at least project, there'll be some shortfall on the demand side, or excuse me, on the supply side to meet the demand. But from an economic standpoint, from what we've seen today, the renewable fuel standard and low carbon fuel standard programs are really driving the economics of this. And we're bullish on both, but you know, it's certainly subject to regulatory risk. So finally, I'm going to speak kind of the downstream, number 4, and where you can get it effectively. And right now, we focus on all our biomethane through our California stations because we can access both credit markets, the low carbon fuel standard and the renewable fuel standard that I was speaking about. But ultimately, this is a look at clean energy's infrastructure across the country. And you know, we're in around 37 airports. We got natural gas highway stations across the country. Those are predominantly LNG. Got a couple LNG plants, have various LNG sources to pick up LNG, and 3 renewable natural gas sources that we own. But as I mentioned, we're working with about 10 other parties who are producing gas, put it in the pipeline, and we effectively take it from there to one of these facilities. And if you saw a weighted move of the gas, it would all be on the West Coast, but it doesn't limit our ability to move to customers that express interest anywhere else in the country. As long as you got a pipeline coming by that's interconnected to the rest of the network, we can deliver a customer renewable natural gas, and they can recognize the benefits of a low-carbon fuel that has up to 90% reduction, and in some cases be negative, as seen on that slide for the LCFS. So we focus on sustainability goals. Long term, I think this is where biomethane is going to make its mark. Obviously, the credit markets help grow supply in the meantime, but if you look at the capital investments that companies are making towards sustainability, whether it be investing in solar or wind or other renewable resources, the beauty of biomethane is it's a drop-in fuel that can meet existing operations and really has limited headaches associated with it. Just I guess a fact check here. Last year we did about 14 million gallons of Redeem, which is our marketed biomethane product at Clean Energy. Again, all that did come from landfill gas resources. Moving forward, again, I think we'll see wastewater treatment plants and anaerobic digesters fit into that mix. But 14 million gallons is a good number, but I think we'll be poised to really effectively double and triple that over the next 18 months. And if you look at the portfolio of supply we have coming online and that is registered, this is all going to be considered cellulosic biofuel. So we're helping the EPA meet its goals. These are some of the fleets looking at natural gas, and again, as a drop-in fuel, we can include biomethane in that conversation. So if you're a supplier or a developer in the space, you don't necessarily have to own fueling stations. You can focus on your feedstocks and the technology to capture methane and purify that methane and really leverage existing infrastructure and investments that have occurred by others on the fueling station side. Certainly it takes collaboration to make the industry go, but the pieces are coming together, and there's a lot of resources out there. Why Redeem? Just a snapshot. Again, it's up to 90% cleaner from a carbon standpoint. It's cost efficient, as I mentioned. We can sell at a discount to gasoline and diesel all day long. It's renewable, from organic waste, and certainly domestic. And here's really a snapshot, kind of a last slide that really reiterates everything I just said. But again, the beauty of this renewable fuel is it can meet the needs of an 18-wheeler or a taxi and everything in between. The electric vehicle, they're moving upwards, but to date it's passenger vehicle limited. I know there's some transit buses out there that are making some headway, but renewable natural gas has as clean a profile, if not cleaner, and probably has less operational issues. So I'll conclude with that and certainly open it up to the Q&A.
That's great, Nick. Thanks very much. I'm just going to flip over to, James Carter here with IMW. I'm just taking the reins for Dave for a little bit here. I'm just going to switch over to our wrap-up deck and make sure everyone knows how to attend upcoming webinars, and then we'll go into an open Q&A session. So you can visit imw.ca/webinars to attend upcoming webinars. We typically have, we should have a few more coming online, so you should be able to book our schedule out till December. Right now we have September 19th confirmed, and that's Why Go Natural Gas, the business case for natural gas in Canada. And that's Alicia Milner, President of Canadian Natural Gas Vehicle Association. Also, this webinar will be rebroadcast in September with moderators in a variety of languages and time zones. So stay tuned for that. We're on board. We're starting a global webinars program and we'll be running at least every other month into 2015 with alternate time zones and several languages coming on. So look forward to serving global markets a little bit more with those. So again, imw.ca/webinars. If you have any questions or would like to make sure that everyone gets their continuing education credits, again, webinars@imw.ca is the email address to reach me. So let's just go to Q&A now. There was quite a few questions that came in here, and definitely keep them coming. We've got a little bit of time here, so we'll make sure we get your questions answered. I guess it sounded like we talked a lot about feedstock sources, and there were some questions about anaerobic digestion from wastewater treatment. Did you guys have any, maybe I could direct that to Steve, what's the viability like in North America for that right now?
There are projects that are in planning right now with respect to recovery of methane resources from wastewater treatment plants. There's a number of them actually that are in place right now that have gone to engine gensets with PPAs and electrical power, being reduced with respect to potential revenues. A number of these now are starting to be looked at as high BTU projects. Typically, when you get into, particularly on the wastewater side, a lot of it will depend upon exactly how the digesters are set up and how much hydrogen sulfide is in the actual gas being produced out of the digester. Those are probably the two biggest functions as to whether or not the economics work out.
Okay, great. Brian is asking, how do I know if I should sell my methane for electricity or natural gas? Is there a formula?
Unfortunately, I don't know of any. We do look at, projects on both sides of that spectrum. We also look at projects even on our high BTU side where we are looking at taking low methane, low quality tail gas and actually producing some electricity to offset our parasitic. Each job, each project is a little bit different. You really need to understand the project specifics, the local area, what type of PPAs are available on the electricity side. Are there any, grants, credits? There's just a multitude of factors to look at, and there's really no good, easy equations used to determine that difference between the high BTU or the gensets.
Dave, just to add on, before too many people, if people are dropping off, there are some resources that I think it would be good to point people towards relating to the whole scope of what was just discussed. The American Biogas Council is a really good resource. Renewable and could dial people in with digester technologies as well as scrubbing equipment. The Renewable Natural Gas Coalition, they're very involved on the policy side and are very informed and are a good resource. As well as if it's specific to California, you got the Bioenergy Association of California, and they're doing a lot in-state as well to keep biomethane with a voice as it relates to policy and really growing the industries out. And I would point people in those directions. And a fourth one would be the Landfill Methane Outreach Program. That could be another good resource, also known as LMOP. But for people on the call that want to dig further into this, those are some really good resources.
Okay. Now, I'm not sure if this was answered earlier. What is the methane concentration in the gas for pipeline injection?
Typically, it depends a little bit on the local utility and what heating value they use. Each utility is a little different. Those values range from about 1,006 BTUs per standard cubic foot to about 1,011. So based on that, you're going to need to be about 94–95% methane to get into pipeline quality. That will depend, of course, also on what your pipeline spec is. Typically, the pipeline specs we deal with on our projects are typically between a minimum of 950 BTUs per standard cubic foot to 967 BTUs per standard cubic foot. But again, that depends on your local utility.
Okay. What types of operating permits are required for a high BTU project?
In our projects, just from a corporate philosophy standpoint, we do obtain our own air quality permit, separate from either the landfill or wastewater treatment plant or anaerobic digester, if required, mainly because we want to have control of our own air permits, so that, we have the compliance, etc. There's a number of other, general types of permits that may involve stormwater pollution, that may involve spill control. All of our plants have SPCC plans. We also have, of course, OSHA standards that need to be met. The other one is just your local building permits, and those, again, are very, very local area dependent. Canton, Michigan, for instance, had a pretty sophisticated program for an industrial activity with respect to inspections, permit drawings, electrical permits, plumbing permits, pipe fitter permits, etc. Some of our other locales in the country are a little less sophisticated. Again, that's a local area. But those are just kind of a genre, if you will, of permits that would be required.
Okay, and one more here. What is the gas pressure at the back end of the processing plant?
In our plants right now, that varies between 175 psi at our Dallas facility is our injection MAOP, maximum allowable operating pressure. Our other two plants are at 300 psi. We have projects in development that go as high as 1,116 psi for injection into pipeline. Again, those tend to be more direct interstate connections. So it can vary anywhere from, like I said, about 170 or so, up in the order of, 1,100 or 1,200 psi.
Great. Okay, guys. Looks like that wraps up most of the questions. There's one last one here. How are the LCOE and where will they go in the next few years? That's levelized cost of energy.
I wish I had my crystal ball is a little foggy on that one. I wish, and I hope everybody, and probably on this call, wishes that it would clear up. I'm anticipating, this is just my own personal belief, but I am anticipating that we are going to see increases in energy costs. A lot of it's going to depend on, the shale gas. There's a number of factors out there in the market right now that affect it, but I do believe we're going to see a general increase over the next 5 years too. So.
Okay. Well, I think that concludes our session. Gentlemen, thank you very much. I think we've covered all of the questions. Just to remind everybody, an edited recording of this session will be available on the IMW website for your use. And again, for the engineers in the crowd who are gathered around a table, please send us a roster of those attending so we can get proof of attendance out to you for your education credits. You can send questions to sales@IMW or webinars at IMW. You can also fill in one of our request for information forms on the IMW website, and we'll be more than happy to get back to you.